So we have discussed about the preparations of aldehydes. In this class, we'll be studying about the preparations of ketones. Okay. So the preparation of ketones can be done in three ways. One, using from acyl chlorides. Two, from nitriles. Three, from benzene or substituted benzenes. Okay, let's see how do we do from acyl chlorides. So preparation of ketones using the alkonyl chlorides and dialkyl cadmium. Okay, so your alkonyl chloride is nothing but the acyl chlorides. Just know that whatever that alkonyl chloride, it's nothing but the acyl chlorides. And whatever the dialkyl cadmium is there, it is the organometallic reagent. Just know this. It is an organometallic reagent. So what happened here? Grignard reagent undergo metal exchange if it is added to metal halide whose metal is less electropositive than magnesium. That means there is a metal exchange will happen when the Grignard reagent interacts with the metal halides. Okay. So what happened here? There will be metal exchange will happen. When it will happen? When this Grignard reagent, it reacts with the metal halides. Okay, so this Grignard reagent, when it reacts with the metal halides, the metal exchange will happen. And how does this happen? The metal is less electropositive than magnesium. Okay, remember this. The metal halide exchange will happen only when the metal is less electropositive than magnesium. I'll show you in the reaction how does this will happen. Just know that. So from acyl chlorides, how do we do? We'll do with the help of metal exchange. What is this metal exchange? When this Grignard reagent, okay, interacts with this metal halide, and so this Grignard reagent will undergo this metal exchange. Just a second. Kiran?
Yes, sir.
Tell me, how does this happen?
Exchanging the metal.
Hmm?
By exchanging the metal.
This is what I told.
No, sir.
When does the metal exchange will happen?
When the Grignard reagent will
React with what?
metal halide.
And the metal halide should be? The metal should be? Less electropositive. Okay, so just remember here, two things will happen. So here two things will happen. One, the metal exchange will happen. And where does this metal exchange will happen? Between the metal halides. Okay, when these metal halides interact with the Grignard reagent. So when does this takes place? It takes place when this metal halides interact with the Grignard reagent, or when Grignard reagent interact with the metal halides. So Grignard reagent interacts with the metal halides, then the metal exchange will happen. But in order to happen this, the other thing is here, whatever the metal we are taking, it should be electropositive. Okay, so metal should be electropositive than magnesium. That means if you compare with the magnesium, this metal should be more electropositive. Okay, so that the reaction will proceed favorably and it forms less polar carbon metal bond. We'll see what is this carbon polar bond. Okay, so metal exchange occurs if it results in less polar carbon metal bond. That means the reaction will show the favorability when the reaction will form a product that shows the less polar carbon metal bond. Understood? So whatever the carbon and metal is there, the bond should be less polar. So this is the product. Okay, this is the product. See here, the metal exchange occurs if it results in, that means it forms the product which should be less polar carbon metal bond. Whatever the product is formed, that product should have the carbon and metal with a less polar bond. Understood? There's a little complicate in the sentence. That's why I'm explaining this much. Understood?
Yes.
Okay. So let's see. So you see here. Okay. So 2RMGX. So this RMGX, it is nothing but the Grignard reagent. Okay. So this is Grignard reagent, and CdCl2. CdCl2 is nothing but the cadmium chloride. And it will form the product which is R2CD, which is nothing but the organocadmium. This is also called as R2. R2 is nothing but it's a alkyl group, right? R is nothing but alkyl group. So this is called as organo and cadmium. This is organocadmium. And then it will form MgXD. Okay. Actually, it's not D, it's a Cl. So which is nothing but the magnesium chloride. So just recall the definition, what I said. So when the Grignard reagent undergoes metal exchange, that means the metal exchange will happen when the Grignard reagent interacts with the metal halide. So see here, the Grignard reagent, when it reacts with the metal halide, then the metal exchange will happen. And it will replace the magnesium. Okay, sorry, it will replace and it will put the chlorine here. Okay, it will exchange the chlorine here. So if you see here, it is RMGX. Okay, and there is a MGX is there. You can see here MGX is there, and it has inserted the chlorine, which is an halide. So there is a exchange of chlorine has happened. Okay, and CD. So if I tell how this reaction will happen, this reaction will happen in four steps. First one is whatever the nucleophile is there, it will attack the dialkyl cadmium. Okay, so this nucleophile will attack the dialkyl cadmium on the acetyl chloride. Second is there is a formation of new carbon-carbon bond. I'll show you how this will happen. And there is a elimination of the metal halide will happen, and there will be generation of the ketone product. So these are the four steps. Actually, it's a little complicated. So first one is one second. Yeah, the cadmium bond should be less polar than the carbon magnesium bond. So only in that case, the metal exchange will happen. Okay, that means electropositivity of cadmium should be less than electropositivity of magnesium. And let's see an example here. First, suppose you see here R dash carbon, double bond O, Cl. So whatever this organocadmium is there, it will further react and form the ketone. Write these points. I'll tell you, write these points. So first one, why do metal exchange occurs? What is the main motto for the metal exchange to happen?
So because metal halide is added to Grignard reagent,
That's okay. But what is the thing that is driving for the reaction to happen? See here. See this point.
Electropositivity of
magnesium.
Cadmium is less than the magnesium. So the first reason is the electropositivity of cadmium is less than the electropositivity of the magnesium. Okay. So the carbon cadmium bond is formed which is less polar than the carbon magnesium bond. Okay. So see here, carbon cadmium bond is less polar than carbon magnesium bond. Due to that, the metal exchange will happen because of the difference in the polarity. Understood this point? If you see here, electropositivity of cadmium is less than the electropositivity of magnesium. Because of that, whatever the bond that is formed between the carbon and cadmium, it is less polar than the carbon and magnesium. Okay, so this is less polar. I can say this is less polar and this is more polar. And if you see here, the definition which I told you here, the metal exchange occurs only if it is favoring for the less polar carbon metal bond. Okay, if the reaction gets a chance that it could able to form the carbon metal bond which is less polar, then the reaction takes place. Otherwise, if the reaction forms carbon magnesium strong bond, the reaction will not take place. Understood? So if it is strong polar, the reaction will not take place. This is not a favorable condition. It should form a product. That product should contain less polar carbon metal bond. Understood?
yes, sir.
Shit, guys, again the power has gone. Yeah, my charging is left in my laptop. Perfect, 60% is there, so I can take the class. Is that clear?
Yes, sir.
So what happened here? Whatever the organocadmium that is formed in the previous reaction, that organocadmium will react with the acid chloride. Just remember, this is an acid chloride. Wait. Sorry, this is an acid chloride. Okay, so this organocadmium will react with the acid chloride and it will produce the ketones, the desired ketones, and cadmium chloride. This is the cadmium chloride, which is a byproduct. Understood? So the Grignard reagent will react with the cadmium chloride. It will result in formation of organocadmium and magnesium chloride. For this reaction to happen, the electropositivity of cadmium should be less than the electropositivity of the magnesium. Okay. So whatever the metal that we are taking here the cadmium metal we are taking, that should be less than the electropositivity of the magnesium, so that the carbon cadmium bond will be less polar than the carbon magnesium bond, which is the driving force for this reaction. And whatever this organocadmium is there, it will react further with the acid chloride and it will give the ketones. Here we will get a desirable ketones. Okay. And here the cadmium chloride is a byproduct. You don't need to remember that one. So that's how it will form. So next one is from nitriles.
So can you show the previous slide? Just a minute.
Anyone have a doubt here? Or you understood clearly?
Sir, could you explain the last part again?
Okay, just listen. I'll explain it again once again. So see here. So what happened here? One second. Whatever the Grignard reagent is there, okay? So it will mainly involve two main components. One is the Grignard reagent and the other one is the cadmium chloride. Here, the two equivalents of this Grignard reagent, it will react with the cadmium chloride. Okay. So when the reaction will happen, it will result in formation of organocadmium and magnesium chloride. Okay. So whatever that cadmium we got, okay, so this cadmium will once again react with the acid chloride. So whatever the organocadmium we got, it will once again react with the acid chlorides, which will result in formation of the ketones. So the first step is formation of the organocadmiums, and the second step is reaction of this organocadmium with the acid chlorides in order to give the ketones. Ketones is our main product. So what we are doing here, we are preparing the ketones. So we got the ketones, and whatever the cadmium chloride is there, it is a byproduct. Understood?
Yes, sir.
But you just
Yes.
understand these two things. These two things are very important. I mean, for NEET level, these two are important. So that's why I'm stressing much. So next one, using the nitriles. Okay. So the treatment of nitrile with a Grignard reagent. So what is Grignard reagent? It's nothing but RMgBr. And followed by the hydrolysis gives a ketone. So let's write a general step. Okay. So how does this will happen? So step number one, okay, the Grignard addition. That means how it will happen is whatever the Grignard reagent is there, it will attack the carbon of the nitrile group. So if you see here, this Grignard reagent will attack the carbon that is present in the nitrile group. And whatever the triple bond is there, it will just go to the nitrogen. Just know this. Okay. So the step number one is the Grignard addition. You can call it as Grignard addition. So what happens in this step is, so whatever the Grignard reagent is there, this Grignard reagent will attack the carbon of the nitrile group. And this will form an intermediate which is called as the imine complex. Okay, that will be containing C double bond N. So just remember C double bond N, which is imine complex. You can see here, there is a C double bond N. Okay. And magnesium bromide will be attached to the nitrogen. Understood? So whatever the carbon is there and nitrogen is there, the bond between them, 3 bonds are present. In that, one bond will be broken, and whatever the electrons are there, they will be shifted to nitrogen. And whatever the RMGBr is there, that will attack the carbon. In that, MGBr portion will attach to nitrogen, and R portion will attach to carbon. You can see here. So here, MGBr, this part, whatever this part is there, this will go and stick to the nitrogen, and whatever R part is there, this will go and attach to the carbon. So that's how you can see here, carbon R and nitrogen Br. Understood how this is formed? So this is called as the Grignard addition. So just remember, in this, Grignard reagent attacks the carbon of the nitrile group, that will form an intermediate complex called the imine complex, which contains C double bond end. And magnesium bromide will attach to the nitrogen, and the other R group will attach to the carbon. So that is step number 1. Step number 2, which is hydrolysis. So what happens here? In the hydrolysis, the addition of water under the acidic condition, H plus means acidic condition, remember. So this is the acidic condition. So we are doing the addition of water under the acidic condition. So that will lead to 2 sequential steps. This is one step, and this is the second step. So hydrolysis will happen continuously for 2 steps. Okay, so there will be 2 sequential steps. So the first is formation of an imine intermediate. You can see here the C double bond N. So that's why it is called as the imine intermediate. And this imine intermediate will further undergo hydrolysis and result in formation of ketone. Okay, so just know this is imine intermediate. This is called as imine complex. This is called as imine intermediate. This is called as the ketone. Understood?
Yes.
Any doubts? Is this clear? So how does the ketones will be prepared from nitriles? You don't need to remember the mechanism, but just know it. Otherwise, it is very difficult to remember the entire reaction. So see here, R, C, triple bond N. In that, whatever the 3 bonds are there, those are, in that, 1 bond will be broken and it will go to nitrogen. And whatever the Grignard reagent, in that, MgBr will attack the nitrogen. Okay, actually this entire compound will attack, but MgBr will stick to nitrogen, whereas R group will stick to carbon. So that's how it will give an imine complex. So this imine complex, under hydrolysis in acidic condition, it will lose the MgBr and it will attach the hydrogen. So whatever the acid is there, the proton is there, that will attach here. That will further hydrolysis, and whatever the NH is there, it will be removed and oxygen will be attached in that position. So that's how from nitriles we will be preparing the ketones. Just remember, this reaction is a nucleophilic addition reaction. Okay, and what does the nucleophile here? The Grignard reagent is the nucleophile. Just know this, which is acting like a nucleophile. So this is a nucleophilic substitution where the Grignard reagent will act like a nucleophile. Understood? So in the first condition, you will be seeing no water present. So this step is also called as the anhydrous reaction. And this is, this reaction is requires anhydrous condition. Whereas this reaction, you need hydrous condition. You need to supply the water here, so that hydrolysis will happen in the acidic condition. So the overall reaction will be forming the ketone. From C triple bond N, it will form C double bond N, and this will form the C double bond O. This is the actual overall transformation. Okay, so C triple bond N, we call it as the nitrile. C double bond N, we call it as the imine, and C double bond O, we call it as the ketone. Carbonyl group. This is a carbonyl group. Is this clear?
Yes, sir.
Yes, sir.
sir.
Mandara?
Yes, sir.
Okay. So tell me. So by this condition, where does the MGBR and all these attached? You can tell you. So first of all, where does the bond will be broken? And where does the MGBR will attach? And where
MGBR
does
will attach to the nitrogen.
Yeah, guys, here RMGBR means Grignard reagent. Sometimes they will not mention like RMGBR. They can give here any R group, any alkyl group. You don't think like this is not a Grignard reagent. It is a Grignard reagent, which is nothing but alkyl group attached to MGBR. Understood? Yeah, Nitya, continue.
So Mg will attach near N, right?
Okay, let's do the reaction. Okay, I am doing continuously from here. I'll do continuous from here. So what will be my second step? I need to break the triple bond.
To double bond.
And here this Grignard reagent will go and attack here. In that, whatever the C6H5 will go and attach to which carbon? Sorry, will it go and attach to carbon or nitrogen?
Carbon.
Yeah. Okay. So that will, let's say, it will attach to C6H5. And whatever the MGBR is there, that will attach to
N, nitrogen.
nitrogen. So this will be nitrogen, which contains the double bond. So it's a what we call C double bond N.
Imine.
Imine complex. This is called as the imine complex. Now what happens next? What is the next step? Hydrolysis in acidic medium. H2O H plus, or you can simply put it as H3O plus. Remember guys, acidic medium with water means you can write separately like water and acidic medium. That's it. H plus is nothing but the proton donor. That means it's an acid condition. Or you can simply put it as H3O plus. So what happens? I told you there will be some other intermediate will be formed, imine intermediate. But where it will remove MGPR and it will attach the hydrogen. Yes or no? I'm not writing the
Yes.
intermediate now. And then finally it will replace all the NMGPR and it will put the oxygen. Yes or no? So that's what it
Yes.
happened here. See here. It removed all the NH and it kept the double bond O, which is nothing but the ketone. So this will be like this. CS3, CS2, C, which will be C6H5, and then there will be double bond oxygen, which is nothing but the ketone group. Understood? So how does this reaction will happen? They will not mention like preparation of ketones from nitriles, give the reaction. They can ask like, so there is a nitrile group when it reacted with the benzene magnesium bromide. They will not even mention the Grignard reagent. In the presence of ether, it will form the product A. And when you do the hydrolysis, or they can say when it reacts with the acidic condition with water, it will give the B product. So what is it? They can give you in statement also. For suppose if you see your pre-board one exam, they gave so many reactions in terms of statements, right? So not always the questionnaire will be like this. It can be in the form of statements as well. So that's why I'm always giving these the names. You should know the names. They are very, very important. So when you read the structure, you also know what is it. Is it a ketone or is it an aldehyde? At least know that. Understood?
Okay,
Yes. Yes, sir.
Yeah. So next one, from benzene or substituted benzene. So remember, this reaction is also called as the Friedel-Crafts acylation reaction. So what happened here? You take a benzene or you take a substituted benzene and you treat that benzene with a acid chloride. Okay, it should be acid chloride in presence of anhydrous aluminum chloride. It will give a ketone. Okay, it will give whatever the type of benzene you take, that type of ketone it will give. If you take a substituted benzene, it will give substituted ketone. Understood? Very simple. You take a benzene, treat with the acid chloride in presence of anhydrous aluminum chloride, it will give the ketone. That's it. So what happened here? Benzene, when you treat with acid chloride, it will give ketone in the presence of aluminum chloride, which is anhydrous. Understood? So let's take an example. So take a benzene ring and you take a acid chloride. It could be aromatic or it could be aliphatic. AR means aromatic. That means it should be a ring or it could be a chain that is attached to C double bond or Cl, which is called as the acid chloride. In presence of anhydrous aluminum chloride, anhydrous AlCl3, it will give a ketone. Now see, observe, where does the bond has broken and where does this attached? That means we are removing the chlorine here. We are breaking the bond between the C double bond O and the chlorine and the halocene. And whatever this part is there, it will go and attach to the benzene ring. Okay, so this will be C double bond O R, or it could be aromatic compound. Understood? So simply you remove the chlorine and whatever the thing is there, you just attach to the benzene group. Okay. So if you want to know more detail about this, actually there is a catalyst activation. That means first step number one, the reaction begins when this anhydrous aluminum chloride, it will act like a Lewis catalyst. Okay. And it will form a complex with the acid chloride. Okay. So due to that, it will generate a very highly reactive asylum. Just know this anhydrous aluminum chloride, it will act like Lewis acid. It will react with this acid chloride and it will form an asylum. Now electrophilic aromatic substitution will happen. So this activated asylum will attack the benzene ring and it will follow electrophilic aromatic substitution. That will form a complex called erinium ion. You don't need to remember. And third, it will result in formation of the benzene ring with a aromatic ketone. Okay, so the ketone group will directly attach to the acyl group that will result in formation of a aromatic ketone. This is aromatic ketone. This is aromatic compound and this is a C double bond O R dash. So it's like R C double bond O R. So which is a ketone. Understood?
yes, sir.
Yes, sir.
And remember, this is very, very important. Friedel-Crafts acylation reaction is the very, very, very critical for preparing ketones from aromatic compounds. Or you can say it is the fundamental method for preparing the uh, ketones from these benzene groups or any aromatic compounds. So I'll give you a quick example. Just note it down. Observe where does the bond is broken and where the attachment is happening. That is very, very important. See here, I took a aliphatic compound. Let's take a aromatic compound. Let's take a acyl chloride, which is a aromatic compound. For that, I'll not be taking the anhydrous chloride. I'll be simply taking here I'll be taking the dry AlCl3. And I should also need an acid here. That will result in formation of two aromatic. Okay, so complete aromatic ketones. So see here, where does the bond has broken? So the bond has broken here. Okay, between the chlorine. It has broken here. And whatever this is there, it is going and attaching here. So that's how it is formed. Understood? So this is one example. This is another example. So come on, quickly answer. What will be the first one and what will be the second one? So we can use a different solvents here. For suppose here AlCl3. Here I used HCl as solvent. In this condition, CH2 is a solvent. It's okay. Don't confuse what is CH2. It's just a solvent. Come on, tell me what will be the product.
Sir, the ketonic group will go and attach to the benzene ring and the chlorine will be left.
Okay, let me draw a benzene ring. It will be having the bond breakage will happen between the carbon and chlorine, and this part will go and attach, right?
Yes.
So C double bond O CH3 plus HCl. Okay, for this, again, where does the bond will broke? It will just broke between the chlorine and this group, and the cadmium will break and between this. So this cadmium and chlorine, they will join together and form the CdCl2. Actually, here there is a small mistake is there. It should be 2 here because cadmium will attach to 2 chlorines. So just know this. So this should be 2 here. So 2 chlorines can attach to 1 cadmium. So result in formation of CdCl2, and whatever this group and this group, they will join together. They will join this way. So whatever the CS3 is there, this CS3, that CS3, and it is having C oxen, C double bond O. And whatever this group, entire group is there, you just write it, CH2, C6H5. So it will attach to CH2, C6H5. You may think, sir, here twice is there. Actually, there are 2 compounds, okay? So for suppose it is like this, C6H5, CH2, C6H5, CH2. That will attach to cadmium, like this. So here this will be broken and this part will go and attach here. This part will go and attach to the other one. Because here 2 CH3s are there. So one will be this, the other will be the copy of this. Understood?
Yes, sir.
Okay.
Yes, sir.
So next one, see here. What will be the product? If you see a CN, it's a nitrile group, that's it. And if it is a nitrile group, this should be RMGBr, which is a Grignard reagent. So from this, you can know what is this reaction is. Preparation of the ketones from nitriles. So how does this reaction will happen? I'm quickly drawing it. Just check whether you know or you understood or not. If you have any doubts, please ask me. I'll explain the mechanism again. Followed by, what is this? Followed by what? What is the second step?
Then MGBR group will, then MGBR group will get
Hydrolysis.
removed and oxygen will.
Yeah, ammonium will be removed here, which will be resulting. Understood? Any doubts? Just observe how it has happened. If you have any doubts, ask me, I'll explain. Okay, I'll give, can I move next?
Yes, sir.
Yes, sir.
Okay, guys, come on, tell me.
Yes.
And this is a very simple reaction, so send me in WhatsApp after doing it.
Sir, I don't have phone with me.
Okay, Nitya, no problem. Others, do it. Come on, it's very simple. ఇప్పుడు ఏం చేసావురా నువ్వు
Sir, chlorine break away. It'll be separated, right?
అవును నువ్వు బెంజిన్కి ఓన్లీ సి డబల్ బాండ్ ఓ పెట్టావు మరి మిగతాది ఏంట్రా అక్కడ ఓన్లీ అదొకటే ఉందా
Oh yeah, that carbon stack.
వాట్ అబౌట్ అదర్స్ కరెక్ట్ మందారా శరణ్
So Sandy.
శరణ్ సి డబల్ బాండ్ ఓ ఏంటి మరి మిగతాది ఏది కార్బన్ ఓన్లీ సి డబల్ బాండ్ ఓ ఒకటే ఉందా this entire will be there no this entire will go and attach here that's it you will be drawing a benzene ring C double bond O put it like this that's it over or else you can draw like this Next one. So the properties of aldehydes and ketones. Okay. So if you see here, order, boiling point, physical state, and solubility. So when we come to the order, the aldehydes, the lower aldehydes, they have a sharp pungent smell. That means very sharp and very, the smell is not good at all. Very kind of abnormal smell. Okay. But if you increase the size of the aldehydes, it will give a very good smell. So that's what happens. If it is a lower aldehydes, the smell is very, very pungent, very dirty. But if you increase the size of the aldehydes, the smell will be so fragrant. It's a very good smell. So just see here, the lower aldehydes have a sharp, pungent odor, whereas the higher aldehydes will be used for fragrance. It has a very good smell. And coming to boiling point, the boiling point of aldehydes and ketones are higher compared to hydrocarbons or ethers. Okay, of a same molecular masses. The reason is the weak molecular association in aldehydes and ketones arise the dipole-dipole interaction. Have you understood what is this reason? What it says? See, what is this dipole-dipole forces? If you see the carbonyl group, it is containing C double bond O. Okay, the C double bond O is there for both the aldehydes and ketones. Yes or no? Does the same C double bond O, is it there for the hydrocarbons or ethers? Tell me. The carbonyl group, is it only present in the aldehydes and ketones, or is it also present in hydrocarbons and ethers? What are hydrocarbons? Nothing but alkanes, alkenes, alkynes. If you see here, the carbon-carbon, if it is triple bond, we call it as the alkynes. C double bond C, called as alkene, CH4. It's nothing but the alkane. So if you see here, is there any C double bond O in these three? No. So there is no there's no carbonyl group in hydrocarbons. What is ether? Can someone tell me what is ether? What is ether?
ROR.
ROR. Can you see any C double bond O here?
No, sir.
You have a carbon, oxygen, carbon, but there's no C double bond O. So ether also doesn't have a C double bond O. So only in aldehydes and ketones, the C double bond O is there. And the dipole-dipole forces is only seen in the carbonyl. They cannot be seen in the alkanes or ethers. So they will not show any dipole-dipole moment. Only the aldehydes and ketones, they can only show the dipole-dipole forces. And what is this dipole-dipole forces? If you see the oxygen atom, okay, which is a very electronegative, yes or no? So we know oxygen atom is more electronegative. And if you see the carbon, it is less electronegative. So the oxygen is mostly the partially negative charge, whereas the carbon, it will show the partially positive charge. Okay, so the carbon atom is less electronegative, so it is shows partial positive charge, whereas the oxygen atom, being more electronegative, carries the partial negative charge. So due to these partial charges, there will be attractive force between the carbon and the oxygen, between the molecules. Okay. So because of this dipole-dipole interaction, that's nothing but one is slightly positive, the other one is slightly negative. That's seen in the aldehydes and ketones. They are strongly attracted to the other. Okay. So they can be strongly attracted to the other molecules. So they will be showing the dipole-dipole interactions. Whereas the hydrocarbons, they do not have any such interactions. Okay, for suppose you take two kinds of ketones, this ketone and this ketone can be attracted to each other because of these dipole-dipole forces. Whereas here in the hydrocarbons and esters, you will not be seen. In ethers, you may be seen, but that's a very weak dipole-dipole interaction. Whereas here in aldehydes and ketones, you will be seeing strong dipole-dipole interaction. Understood? And the stronger intermolecular attraction is there, you need a more amount of heat. Yes or no? So when there is a ketone, is it attached to another ketone with a lot of with a strong some kind of strong bond. In order to break the bond, you need a lot of energy. So that's why the boiling point is for aldehydes and ketones is somewhat higher than the alkanes, alkynes, and ethers. Have you understood? If you just know what is ketone, for suppose what is nothing but boiling point from the liquid to, sorry, yeah, from the liquid stage to the gases, that point is called the boiling point. Yes or no? First, suppose in the liquids, the molecules are condensed, whereas in the gases, they are separated. And why they are condensed here? Because of these dipole-dipole interactions, they made a bond from one ketone to other ketone. But if you spread them across with a wide range of gap between them, you need to break the bond here. For that, you need a high temperature. So when you provide that high temperature, the bond is broken and they will be moved far distance from each other. And that's how from the liquid state, they will be converted into the gas phase. Understood? So in order to separate the molecules and convert them from liquid to gas, you need a more energy here because you need to break the bond that is formed because of strong dipole-dipole interactions. Whereas you don't need to break that bond in the hydrocarbons or ethers. They can easily separated. Whereas here you need to provide supply energy. So that's why the boiling point is more. I'm telling this because you need to know what is boiling point also. Don't simply remember like the liquid convert into gas because there are interactions and the bonds formation between the molecules and molecules, we need to break those bonds. For that, energy is needed. So that energy is provided different for different molecules. And here, the aldehydes and ketones will be having more boiling point compared to the hydrocarbons and ethers. Understood? So you
Yes,
can
sir.
see here, this is one ketone, this is another ketone. And this is positive charge, this is negative charge. So they will be having some kind of short bond. And here there's a some kind of intermolecular attraction is seen because of opposite charges. And that's called the dipole-dipole interactions, which is intermolecular. Okay. Next one. The boiling point for the aldehydes, ketones are lower than those of the alcohols. Okay. Why? What is the reason? We said that the boiling point for aldehydes and ketones is more than the alkanes, alkynes, and ethers. Yes or no? Whereas here, the boiling point for aldehydes and ketones is less than the alcohols. Why does the alcohols are having more stronger boiling point compared to here? For suppose if you see the hydrocarbons between the molecular and molecular, they will be having van der Waals forces. You might have studied in the 11th. Whereas in the ethers, the dipole interaction will be there, but that is very minimal, very less. Whereas in aldehydes and ketones, strong dipole-dipole is there. Okay. And if you come to alcohols, what could be the reason for the alcohols that is having much more stronger bond between the molecules compared to aldehydes and ketones? So what is the phenomena? For suppose what is alcohol? It is nothing but ROH. And what is aldehydes and ketones? It is R double bond O. So due to the presence of this OH group, it will enable strong hydrogen bonding in the alcohol network. Okay, you take the ROH, you take the other ROH, in between water is present, there will be strong hydrogen bond between hydrogen and hydrogen. So that will make a group of molecules. And this strong interaction will make them stick together. They will not be widespread, they will be close to each other. Understood? So what is the reason? It's because of this strong hydrogen bonding network that is seen in the alcohols. So the absence of intermolecular hydrogen bonding in aldehydes and ketones. In aldehydes and ketones, we have a dipole-dipole. Whereas in the alcohols, we will be having the hydrogen bonding. Hydrogen bonding is stronger than the dipole-dipole interactions. Okay? Understood?
Yes.
Yes, sir.
So you can see here. So one alcohol is interacted with the other alcohol because of that. See, I'm explaining this much because you will never forget. Okay, don't just remember like aldehyde and ketone will be having more boiling point than the alcohol, and aldehyde and ketone will be having less boiling point. I mean, less boiling point than alcohols. It is less than alcohols, and it is more than hydrocarbons and ethers. So don't just simply blindly remember like this. Understand the reason behind. So you don't need to mug up. So just know aldehyde and ketone, they are having C double bond O. So due to dipole-dipole interactions, they are forming the attraction between the molecules. Whereas here COH, hydrogen bonding is formed. So they are strongly bound. Whereas here, no such bondings are seen here. Okay, neither the dipole-dipole or hydrogen. So these are very weak van der Waals forces. So they can easily separated. So require less amount of energy, less boiling point. So that's it. Next one. The physical state, methanol will exist as a gas in the room temperature. Ethanol is somewhat volatile liquid, and aldehydes and ketones, other aldehydes and ketones, mostly liquid or solid at room temperature. That means ethanol can easily spread into gas form. From liquid to gas form, it can easily spread. So that's why it is a volatile liquid. Whereas methanol, it always exists in the gas form at the room temperature. Whereas these aldehydes and ketones, they are liquids. They are liquid states. Other aldehydes and ketones. So next one, solubility. The lower members of the aldehydes and ketones are miscible with water in all proportions. What is meaning of miscible? What is meaning of miscible? Come on, you might have studied in class 10th or 9th.
Sir,
What
is
is
it
miscible?
clear?
Yeah, it is clear. Okay, so miscible means, remember, it can miscible. Miscible means it can able to form the homogeneous solution. Okay, that means it has the ability to completely mix up with the water. Okay, you take any number of, I mean, R, you can take any number, but still it can easily mix up in the water because they form hydrogen bonds with the water. And those which can able to form hydrogen bond with water, they are very good soluble substances. Okay, so here the aldehydes and ketones, they can easily mix up with the water. Okay. Next one, if you increase the length of the alkyl chain, the solubility will decrease. Okay, so all aldehydes and ketones, they are very good soluble in organic solvents such as ether and methanols. That means non-polar solvents. Okay, so next one. So predict the following. Shall we stop here or continue? Okay, let's start. Three slides are there. If these are over, that means the physical properties are over. Then we can start chemical properties in the next class. So tell me, predict which of the following will have a lower boiling point than butanol. Butanol, which is nothing but a aldehyde. So which one will be having lower boiling point than an aldehyde?
1 BT.
I can clearly see there's only one option is there.
Option C.
Yeah. Option C. I told you, hydrocarbons, they are less compared to aldehydes and ketones. And these are less compared to alcohols. And you can see here, this is an alcohol, this is an alcohol. None of these is not an option. So this is the only option. Understood? So just know alcohols, they are having the higher boiling point compared to these aldehydes and ketones. Okay. And why does these alcohols are having higher boiling point? Because they can able to form intermolecular hydrogen bonding. Okay. So these can able to form intermolecular hydrogen bonding. Whereas these can able to form dipole-dipole interaction. Hydrocarbons doesn't show that much of any interactions. Okay. So these is much stronger compared to the hydrocarbons, and alcohols are much stronger compared to aldehydes and ketones. Next one. So tell me, what is this? Okay, don't tell out. Send me direct. Except Nitya, send me all in WhatsApp. Nitya, you send me in chat when I ask you to send. Or you tell me when I ask you to send. When I ask you. Yes, Sharon, that is correct.
Sir, I have sent it here because my sister's having the phone and she's down.
Okay. Mandara, your option is wrong. Shrikar, you are correct. Nitya, what about you? Is
Sir, I
Nitya
was
in the class?
not there. Sir, I was not there in class past 10 minutes, sir.
Okay. What happened, Nitya?
The laptop shut down
This time whose
suddenly,
birthday?
sir. Sir, my laptop shut down suddenly, sir.
Okay, okay. I thought this time your father birthday and Uncle Small came.
No, sir.
Okay, see here, the boiling point of aldehydes and ketones higher than the hydrocarbons and ethers of comparable molecular masses. Is this true? The statement? I told you clearly, aldehydes and ketones are more boiling point compared to hydrocarbons and ethers. And there is a weak molecular association in aldehydes and ketones arising out of dipole-dipole interactions. Yes or no? This is also correct, right? So I told you, see, weak molecular association, but that doesn't mean it's a weak dipole-dipole interaction, okay? So that means one ketone, the other ketone, they will show the association. For suppose you take a jar, in the jar we'll be having different number of ketones. Okay, there are a lot of ketones are there. But one ketone to the other ketone, the association is weak. But the association, whatever the weak association is there, that is due to the strong dipole-dipole. If you confuse, maybe weak molecular is weak dipole-dipole, but SAR has said strong dipole-dipole. Yes, of course, it's a strong dipole-dipole, but that association is weak. But if you see alcohols, due to the OH, they will form a strong association with other OH. Okay? Understood?
Yes, sir.
So the option A is correct. He has given the reason. The reason is saying the bond between the aldehydes and ketone is due to the dipole-dipole interactions. And that's a weak molecular association. And if you see the hydrocarbons and ethers, they will not have any association at all. Okay. So that's it. We'll talk about the chemical properties in the next class. We'll stop it here. Let's call off the day. Good night, guys.